three-way switch project is going to be a little different. You're going to need to go on Blackboard and print out the pictorial diagram for the three-way switch project. Now this is going to show you component arrangement, how you should set up the boxes. This is not the ladder diagram. It's a little bit different for mostly troubleshooting. Pictorial diagrams actually show the components, okay? There's going to be something different between the three-way switch they're showing you here on this diagram and the three-way switch you're actually getting from this manufacturer. They have a different common terminal. They show you this one off to the side. It's a single screw as the common terminal, whereas on this one here, the single screw is not the common terminal. All right, can you tell me a difference though about the screws though? Like, what's the difference between those two? One's what? One's gold or brass, and one's black. The black one is going to be the one that's a common terminal. Now, when I'm using the term common, all right, that's not the same common as I'm talking about as a neutral wire. This common just means, pass me that meter right there, that it shows that it shares this terminal with the other two screws. So this is the most important one. The one coming up on this side from the power source, the hot wire, has got to get tied to this common screw. And then on the other three-way switch that you're going to put on the other side, this common screw has got to go to the light fixture, to the brass light fixture. Where is the light fixture, by the way? There was a piece, a plastic piece, goes with it. All right, so let me show you something. So I take it and I put it, hold the meter up. Take it and I put it on one, right here, on the common terminal. And depending on, there's no on or off now with these three-way switches. There's no on or off now with the three-way switches. It doesn't say on or off anymore. It just says right there, blank. So when it's up like that, the common's going from here to this screw. Hear how it tones? And then when I flip it down, it's not to that screw anymore. It went over to the other screw, the other pole. So this is a single pole because it has one power source coming in, but it's now a double throw. Where the other switch was a single pole, single throw, it was either on or off. Depending on the position of this switch, whether it's up or down, is going to determine which side the power is going to through the switch. Okay? So the screws that are brass, doesn't matter what color wire you hook up to them. It could be a red wire, could be a white wire, could be a black wire. And that brings me to another point. The other point is, now that you're using a white wire, right, for one of the traveling circuits going from the fixture box over here to your other outlet, it's going to have 120 volts going to it. So just because it's white doesn't mean that it's common. We always use common as white, but just because it's white doesn't mean that it's common. So it could have some power going through it. And this is where it usually gets confusing for a couple of the students, because you got the white wire from the power source getting tied and going directly to the light on the back here with the silver screw. And then they got another white wire that goes from this box over into here. That's the one that could have 120 volts to it. So if you mistake the white wire, and I'll show you when I'm wiring it up, for the one that's the neutral coming in, and you tie it to the black, and you turn it on and plug it in without testing it with the meter to make sure that it's working right, it will spark up. It will short out. Okay, so you just got to make sure that we're using the right white for the neutral and the other one for the travel. So, all right, so I'm going to go ahead, I'm going to screw down my boxes. If you're lucky, then you can use the previous holes from the other person. But before I screw down the boxes, you're going to be using these EMT connectors now, because this is what you're using, the electrical material tubing. All right, they also call it conduit, and there's some code to it. In other words, if you look above you, you can see all for the power, for the lights and everything. And then you notice they've got about a strap or some sort of clamp every 6 feet or so. All right, so if this was a real long run, you would probably have some clamps holding this pipe in place. All right, but for you guys, you're going to be making some short runs, a little 2-inch piece of EMT. If you cut it and it gets out of round, it won't work. You got to make sure it stays in round. Okay, so you got to make sure that it's in round, and you're not, when you're cutting it, you're clamping it with the vise. It's not getting out of round, or else you're not going to be able to shove it in. It's got to be perfectly round. And the set screw. Don't take these screws all the way out. Set screw's got to be backed out enough to where it can slide in, and then you can take, once you get it in place, lock it in with a set screw like this. A little different than the Romex connector. All right? Boom, like that there, and that's it. And then if you had a really long run of pipe, we would probably have to fish wire one piece, a solid wire, they call it fish tape, one way if you were trying to pull more than one conductor through the conduit. So they would push it through like that, all right, and then you would attach, make a hook like that, and then somehow attach all your other wires at the same time. All right, you wrap these around like this, and then you get some electrical tape and you tape up both ends. And then what would happen is one guy would be on one end of the pipe with all the wire, feeding the wire in so it doesn't get all chewed up around the edge of the connectors, and another guy would be on the back end like that. Go ahead and pull that. And he would be pulling it back through, and then that's fishing. Now you're fishing the wire, okay? So that's how they get the wire in really long runs or even short runs with a couple bends, because especially if it's stranded, you can't really push it through like this. After it gets about 2-3 feet, it starts to bind and gets a little harder to push through. If it's just one wire, it's not a big deal, but if you got more than one conductor going through, which usually you do, and then code also dictates how many wires I can run through this 1/2 inch. If I got like more than 6 or 7 wires and it starts to get tight, I got to step it up to a 3/4 inch piece of conduit or a 1 inch piece of conduit. Okay, so that all determines a little bit about, with the code, determines how many wires and conductors you can put through. So you're going to need, before you, don't screw down the boxes first, although that's what you did first last time, you're going to need to set up your pieces with your EMT connectors, and you're going to need to lock them in first and build the project up with the boxes, and then you can screw it down. All right? You can go ahead and stop for a second. So now you're going to need to make a ground. The ground you're going to run is going to be insulated. So you're going to need to strip some back. What I'm going to do is I'm going to go ahead and I'm going to strip a little bit back off here like this, because I want to show you something. I'm going to run this through. You're going to need a ground going through all 3 boxes. Technically, this is your ground. They don't even really need to run a ground when they run all these metal boxes in EMT, because if they connect the ground to here at one box and all these connectors are tied in tight, then they're connected together. They're bonded. All right? But what happens if some kid comes along and loosens up a screw, and then the strap comes off down here on this one, and this pipe pulls away from the connector, and the bond, or the box, is grounded over here, and all they see is these wires sticking here, and there's no ground. So we've lost our bonded box. We lost our ground. So we're going to also run a ground to make sure that doesn't happen to each of the boxes, but technically sometimes the electricians, they won't even run a ground. They'll use the conduit as ground because everything's metal. But if it comes apart, then you lost your ground. So we're going to bring a little loop in here like this, and then I'm going to bring it, and I'm going to use all one piece. So, but you're going to need about that much there, 6 inches coming out here, and I'm going to actually start back here and strip back here a little bit. And I'm going to actually strip a little bit off, not all the way, but enough. But right, let's see, where we lose it, right up in here. All right, boom, like that there. So that now I can run it in here like this, and I can just wrap this around the screw. All right, the screw's a little close to my connector, but it'll go. There's one in here. Like that. Get it wrapped around, and then you can lock it down, and you already got your pigtail. You already got the pigtail sticking up. So you see that? Now I've just stripped them out, and we already got our pigtail, so all I need to do now is make a hook, and we're ready to connect up to our switch. Still need to do one here, and I'm going to need about 6 inches back here. So I'm going to go ahead, and you could also, sometimes if you want, you can just cut the wire insulation in 2 different spots, and then some guys can shave it. You like to shave it, all right? You can shave it like that. All right, and once you get it to the next cut, you should be able to just peel it off. So that's one way of doing it, to get a piece out like that. And you just come down like that. Now I've got it off like that because I cut, but didn't cut the wire, just cut the insulation. Or if it's real long, you can do it, but it starts to bind up a little bit when you're pulling it, and it's really long like that. So it's up to you what you want to do for the center one. You can slice it a little bit, or you can try and pull it a little bit. But I had one screw up, so I'm going to go ahead and make sure it hooks around the one screw, tighten it up, and then move it on to the next box.
Is there an Oscar in here?
No. That's next class, period, what is this, 2? It'll be period 1.
Okay. Thanks.
Something there.
Thank you, Ryan.
that one around here. All right, now I'm bonded. The box is grounded. I can push this ground down out of the way now, and we're all done with it. And I got the 2 pigtails for my 2 switches. That might be a little loose. We might have to do that one again. Okay. So now you're going to fish the rest of the wire through. And now I'm going to give you the power cord last again, but you're going to need a red, a white, and a black going from one box to the other. And if you take a look, you can't see it on this picture because it's black and white, but there's one that's a little lighter. Not quite white, not quite black. It's a red one. Okay, so that's going to be my red wire. And you see on the diagram, they have it tied with a wire nut in the center fixture box. We're not going to do that because you're running the wire from one to the other. What I'm going to do with the red is I'm going to go ahead, we're just going to fish it through, and you're just going to loop it, but you're not going to cut it. So bring it in, give it a little loop like that, and push it all the way through to the next box. Okay, make sure you got enough, because normally, like I said, if you used Romex 14.3 instead of the conduit, the EMT, you would have to probably have 2 different red wires wire nutted together. But because we're running it through conduit with all one, you're just going to loop it like that, push it down, be done with it. That's it. Don't need to cut it, don't need to do anything. Make sure you got your 6 inches still on either side. So now the red one's done, and I just need a white and a black to go from each side over. Okay, coming out like that's good. A little bit more over here. And that's it, the rough end's done. So now I've got all my wires ready for rough end. Okay, I'm going to go ahead and do the light fixture first. So if you take a look at the diagram, the white one that comes from the left side with the power source is going to go right to the light fixture. So that's this white one right here. And this way I do this first, I don't get it confused with the other white one that's going to have 120 volts flowing through it. So go ahead and set this one up, make the hook. Alright, and then the other one for the light fixture is going to be the black coming from the other side. So the black one coming from the other side here is going to be the one for the light fixture as well. And that just leaves me the other 2 to wire nut together. We're probably going to need 2 yellow wire nuts at some point. So I got those set. White to the silver screw. Tighten it up. See how much that pulled up? Alright, when it was really low, and then make sure you also set the other screws. If you're not using them, tighten those all the way up and set them down. But you see how much I got insulated, uninsulated, sticking out? Watch, this is why you do it with the tightening of the screw. So by the time I pull it down, alright, and I give it a really good tighten, it'll pull that uninsulated part up and make a complete loop if you do it right. But you got to have it really in. See that? Pulled it up. Then I can just push it back under the tooth like that, and we're good. So that's it for the light. The light's done. Now I can go ahead and I can either do this part here, which is going to be a wire nut, so I can cut these. And just tie them together with a wire nut. You could twist them together at first and then cut it, put the wire nut on, or you can use the wire nut. Just make sure there's no bare wire sticking out below between the wire nut section, that last part that doesn't have any grip to it, okay, those little ridges. So you might have to trim it back so it's about 5/16 of uninsulated wire, and then twist them together. And then again, see, I don't see any bare wire, and there's no insulation up underneath the metal part either, so that's good. So that's done. So now all that's left is the 3-way switches. So I'm going to go ahead and I can hook the ground on first. We're going to go ahead and hook the ground up, tighten that up. hook ground up over here. Now, which one did we say was the most important ones? Red? Red's important? No, I don't think red's important. We said something about
The common.
the common. Which one's the common?
Black.
The black. No. Neutral common's different than the common on my switch. So, which one went to the commons? What did we say was important about the commons?
The
power.
The power cord. So I need my power cord. Somebody took my power cord. I had a power cord that went with this. All right. And then the other one went to what?
The black one goes to the common.
To the fixture. The black one goes to the common on that screw there. That's good. Thank you, sir. All right. So I'm going to go ahead and hook this one up. Common. It's going to go right to the light. I already got it. Alright, and then my other common. Now look, if you got the two from the previous project, alright, you're going to need to cut one of the terminals off. Alright, one of them is the only one that you need on the hot wire. The other common is going to get tied with a wire nut in that box and get pushed down. So you might have a white and a black, and you might see one with a terminal like that. Alright, so I could use that one because this is the one that came from the project. Which one was the hot on this one though? Smooth. So make sure to go with the smooth one on the common terminal. The rough one and the ground you can either hook here, or I could put a terminal on it and put it underneath one of the screws there. It doesn't matter. But you're probably going to need, you're not going to need both spade fork terminals anymore. You're not going to need any more of the solderless terminals on the neutral wire. So I'm going to go ahead, I'm going to shove this one in. I'll put it in here like this. It's easier if you didn't have it already stripped, but it'll go in. Alright, and you need about 6 inches or so, and then I can go ahead and tighten down this connector. Hot one to common. Now, white one, a neutral wire. I'm going to go ahead and strip a little bit off that. And then if this is messed up, you need a little bit more, go ahead and get a little bit more. Now, how much should the stranded stick above the solid before I put the wire nut on? Anybody remember that? About 1/8 to 1/4. About 1/8 really. About 1/8 of an inch, right? So the strand has got to stick up above the solid for it to catch in the screw. Alright, and then what it'll do is it'll catch the stranded pieces first and wrap around. Wrap around. It'll wrap around. Yeah, no insulation showing. Wraps around. And then the biggest part is you got to pull on it to make sure it doesn't come off. Okay? No coming off is good. And then I'm going to go ahead and just do my ground real quick. Now, we can make it all one piece and make a hook and just attach it, but I'm going to go ahead and use the spade terminal. Fork. Teeth. Lock it in. Crimp it down. I used the wrong. I'll put it on the back side, but I think I can get it. Alright. And then to make sure it doesn't pull off. And then I can just loosen up that screw on the bottom and slide it right underneath the screw head. And that'll be grounded. it is. So now I just got about everything done. Now all that's left is a red and a white over here, and all that's left is a black and a red over here. Now it doesn't matter. It doesn't matter what color. I can put the black one on that side, I can put the red one on that side, I can reverse it. It does not matter. Once you get the commons taken care of, all right, then it doesn't matter. So I'm going to go ahead. No, we're good. Try and keep the wires from getting twisted up and on top of each other inside the boxes. It'll make it easier when you need to push them all down together in the box to put the screws in. So you can kind of keep them from getting all twisted. That'll help you out a little bit. So that's it. I'm pretty much done. Now, again, if they got these wings, you need to get the wings out. Cut those little tabs off for the drywall because we're using metal boxes and that's for a drywall box. What? The plastic? Some. You could have a metal drywall box. It depends on the thing. Now look, you can either cut them straight up. Should have goggles on because that piece could fly across the room. Or you can take it with needle nose or Lyman's and wiggle them right up against the cut. Doesn't matter what you do. Both ways work just as good. Alright, so that's it. I'm done with the wiring. Now let me show you what happens. Hold that up. So you need to do the same thing. You would have everything pushed down. This is how I'm going to leave it for this project. I got another one that's complete over there, but this will allow you to see this one. So this is about as far as I'm going to go with it. But you need to make sure everything's bonded. Okay? The boxes, the switches, we're all good. Ground. But you should not have any continuity to any of the polarity plugs, all right, on one side or the other to ground. That means you have a short. But what happens here is, let's see what that is. Is that okay? So that's my neutral on the left, all right, and that's it. That won't have a break to it. That neutral goes right through here, through the wire nut, and in here. Boom. All right. Then now the other one is off right now, and then you come down here. Let's see. Wait a minute. Let me switch it over here, and it's off. Okay. So you come over here and you turn it on, and then somebody else at the other end of the hall turns it off. Okay. How is that working? Well, right now, we've got the power coming in here. And remember I told you it's double throw, so depending on which position this is, determines, okay, so it's going through the red. It's coming down here through the red. We didn't break the red, so the power's waiting over here. And it's waiting for you. It's not going to jump up here till we get the switch. There, see that? See how that works? All right, and now we've got it going back through this black, through the common, to the light. So the light should be on right now. And then you go down to the other end of the hall, and oh man, we're not breaking at the red anymore. We flipped this switch up. So now it's over here at this black. The black goes to the white, connects over here. So it's there, but it's waiting here at the light for you to come along and turn it back on. Okay? So now what we got is we got a traveling circuit, all right? A traveler, where the power can, that's why you need that red wire. It's because it's going to go through one wire one time, and then when you break the contact, it's going to wait for you to make contact to get to the other wire to energize the light. So once everything's done, let me see that light bulb. I'm going to plug it in without. Just be careful because you're not going to do this. You're going to have them all tied down with the switch. Let me see. We don't need the meter anymore. Let me see that power cord right there.
There's one to your right.
I know. I don't want that one. It'll get in the way of the video. Can't get in the way of the video. Alright, so look, careful, there's power there, but wow. Go to the other end of the hall, turn on, turn off. And then if you get really good, some people can do it without even making a light. Oh, look at that, huh? Or you can turn it off without letting it blink, huh? Oh. Or if you really want to get disco.
It's like in some apartments. It's like
No disco. All right, so that's the three-way. You need to buy, what you're going to have to do also, you're going to have to build your own material list. Tell me what you used for this, list it all down there, and we're going to convert this diagram that's a pictorial to a ladder schematic wiring diagram that's going to show you how to do it. So I'm going to leave this one open for you to be able to see the wiring, but don't touch it, don't plug it in, you're going to have everything pressed down with the cover plates on by the time you turn it into me. Everybody understand that?
Yep.
All right, good to go. Thank you.